aspect of our work that we've focused on relates to the desalination brine, and this brine will obviously be highly concentrated in salts, but also in a range of contaminants that are used as in the processing plant, things like descalants, chemicals, those sorts of things. From other desalination plants around the world that the water that goes back out in the Gulf will actually have be higher temperature and potentially also higher turbidity levels. So sediment and things could be actually in the water. And there's evidence of decreased oxygen loads in some plants, and that was initially found in the Perth desalination plant. There will be the release of, obviously, as mentioned in the BHP Billiton DVD, of this high salinity brine that will sink to the bottom, and this is what has potential not only to impact adult mating behaviours, but also those benthic or bottom life history stages. So cuttlefish don't really like moving up off the bottom throughout the water column, and there is potential to impact these life history stages. So what we did here, largely because BHP wouldn't tell us what their results were, was to run our own experiments. Now, what this graph shows is just an example of what's in the actual water. Besides salt, you also have a range of other elements, things like strontium, calcium, potassium, magnesium. Now, this dotted line here represents what the concentration out there off Point Lowly currently is. These are 2 replicate tanks, or the concentration of magnesium in 2 replicate tanks across a range of salinities. So you can see here, as soon as you start increasing, this would be the background level, above about 5 grams per litre more, you start increasing the concentration of some of these elements. And we know from overseas work that high magnesium can cause mortality and reduced mobility in cephalopods, so other squid species or cuttlefish species. And we can see that there are higher concentrations at these higher salinity levels. Now, I've just shown you the data here for magnesium, but we see similar patterns for other elements. We also then looked at the hatching success of the cuttlefish. Here, what we've done is raise the eggs, and you can see a little embryo up here with its 2 little eyes. Raise those eggs from pretty much the time they were laid through to the time they hatched in different salinity waters. And our results are quite similar to what BHP's found. Pretty much as you increase salinity, you decrease survival. So we're not talking about a massive shift here. We're talking about moving from 40 to 45 parts per thousand or grams per litre. You've got a decrease in survival, and up at these higher levels, total mortality. Besides seeing a decrease in hatching success, we also, at that higher salinity, get smaller individuals. And this may actually have potential implications for how well they can feed or how well they can swim. Now, all of this may be fine if that plume disperses to background levels and doesn't reach up into the shallow waters like one of the guys, James, I think it was, on the DVD was suggesting. But if that doesn't happen, and there's a few reasons why it may not totally happen, or if there's potentially fluxes of water, of brine water up into the shallows, then there is actually potential to impact that benthic life history stage. One of the things that was addressed at EIS is that they did do a series of ecotoxicology studies. As James suggested, they did it on a whole range of species, but they seem to have done different things on different species, and even when they ran the same tests on the giant Australian cuttlefish across a couple of years, they used different salinity waters to dilute the brine, making it extremely difficult to follow exactly what they've done. Okay, so there is potential out there to impact that benthic life history stage, I believe, but it's highly dependent on what happens with the plume of brine that's released. There's also potential to impact the adult mating behaviour. Cuttlefish are very visual. If you go and you dive on them, you snorkel on them, they're looking at each other. They've got chromatophores, or the colours going along them. They're showing off to each other. So if they can't do this, or the other cuttlefish can't see them doing this, that could mean that they don't reproduce at all. Now, there's been absolutely no work done on the adult side of cuttlefish in terms of whether their adult mating behaviours will be impacted by higher salinity. The other thing that is of some concern relates to the inbound migratory routes of cuttlefish. So they lay the eggs out there between May and August. They hatch out. The little cuttlefish, size of your thumbnail, disappear. We don't really know where they are, but from our molecular genetic work, we would suggest that they're restricted to Upper Spencer Gulf. They then have to come back in to that small area of rocky reef habitat to lay the eggs. And remember, that is the only area of rocky reef available in Upper Spencer Gulf for them to lay eggs, along that coastline and slightly further north. So they can't just go, oh, I'll move over to Port Pirie. There isn't the suitable habitat there. So I guess my concern is how they'll move into that habitat, whether that brine that's potentially there will impact them. This is straight out of the EIS. They've got all these diffusers. The brine will move up into the water column and then sink back down. They're talking about it moving between, this is straight off their graph here, between 3 and 7.5 metres above. If the cuttlefish are 0.5 metres above the surface, they're quite bottom associated. We don't know that. This is also straight out of the BHP EIS. This is the 0 to 45 dilution and the 45 to 85 time dilution. We shouldn't ever see the brine plume being greater than this, so this is the worst ever dilution possible. Will cuttlefish be able to disperse through this plume? We don't have any information on that. BHP hasn't given us any information on that. These are also, they're 1%, so it shouldn't be worse than this more than 1% of the time, and it shouldn't be worse than this more than 10% of the time. So cuttlefish still potentially have to go through some sort of plume. Okay, if we start looking at use of adjacent or habitats adjacent to the reef, in the EIS they state that they did search some of the habitats offshore from the reef. So we've got Point Lowly up here. They searched out here and might have been one cuttlefish. They also refer to a study that they said found no cuttlefish out from the reef. They didn't focus on over 10 years of information that Sardie Aquatic Sciences has, some of which is actually published. These are trawl sites that Sardie Aquatic Sciences has used in Upper Spencer Gulf, and as I said, they have sampled those sites between 1999 and 2009. They're sampling them primarily to look at recruitment of snapper, so pink snapper, but while they're sampling, they also record the numbers and biomass of giant Australian cuttlefish.